This is video 6G for the Year 7 Mathematics course. In this video, we're going to be covering the theory behind cancelling common factors under the topic of fractions. Specifically, we're going to explore a revision on lowest terms, how to write a fraction in lowest terms by cancelling common factors, and then we're going to cover some example questions. We recently introduced this idea of writing fractions in lowest terms, which, just as a quick reminder, is effectively the idea of writing a fraction with the smallest possible integer numerator and denominator values. And the way that we tackled this process in the last video was by dividing the numerator and denominator by their highest common factor. So, just to give a very quick example, let's say we were given the fraction of 15 over 20. The highest common factor of 15 and 20 is 5, so we'll divide 15 by 5, and then we'll divide 20 by 5 as well. What this then results in is 3 over 4. So what we would say here then is that 3 over 4 is written in lowest terms, because 3 and 4 do not have any more common factors other than 1. What we're going to be focusing on in this video is a slightly different way that you can think about this process of turning a fraction into its lowest form. And so we're going to use the exact same examples up here. So we're going to consider 15 over 20. Now I'm sure that we can all agree that 15 over 20 could get rewritten as 3 multiplied by 5 over 4 multiplied by 5. Now, it turns out that when we're considering fractions, we have a very nice rule that we can use when we have common factors on the top and bottom of the fraction. It turns out that we can cancel these common factors. And when I say cancel, I literally mean you get rid of this one and you get rid of that one, because 5 is the only common factor that appears on the numerator and the denominator. So then what are we left with? We're left with the 3 on the top, and then we're left with this 4 on the bottom, which, as you should notice, gives us the exact same as what we did when we performed this using division. So this is the process of what we call cancelling common factors, which is effectively where we factorize the numerator and the denominator, and then we get rid of any numbers that appear both on the numerator and the denominator. Now, the really key thing to understand here is that even though this process may look a little bit different from what we've done up here, it has the exact same effect as simply by dividing by the highest common factor. So at this point you might be saying, well, why do we have two different processes if they're just going to result in the exact same thing? And realistically, at this point in time, there's not really a good answer that I can give, because when we're simply working with regular numbers for the numerator and for the denominator, there really isn't that big of a difference between simply dividing by the highest common factor or by cancelling common factors. The reason why we introduce this idea here now of cancelling common factors is because when we get into algebraic fractions, in other words, when we have a's, b's, c's, x, y's, and z's on the numerator and the denominator, we are going to be strongly focused on this idea of cancelling common factors. So we're just introducing it now such that when we get to the algebraic fractions, it does appear a little bit more natural. Alrighty, with that now being said, let's have a look at a few examples of writing fractions in lowest terms using the process of cancelling common factors. Alright, the three fractions that we're going to consider are 20 over 26, 18 over 32, and then negative 4 over 6. Starting with 20 over 26, we of course know that we can rewrite 20 and 26 as 10 multiplied by 2 and then 13 multiplied by 2. The common factor that appears on the numerator and the denominator is 2, so we can now cancel these common factors. Put a cross through this one, put a cross through that one. So therefore, what are we left with? We are simply left with 10 over 13. Alright, let's consider the next one, 18 over 32. We know that 18 over 32 can now get rewritten as 9 multiplied by 2 divided by 16 multiplied by 2. Now we can cancel any common factors, which in this case is simply this 2 and this 2. So now what are we left with? Simply 9 over 16. And then finally we have negative 4 over 6. So we know that we can rewrite negative 4 over 6 as negative 2 by 2 over 3 by 2. In this case, the common factor is 2, so we can cross out this 2 and this 2. Just a quick word of advice here as well, be very, very careful to make sure that the amount of things that you're crossing from the top is identical to the amount of things that you're crossing from the bottom. A very common trap fall that I see a lot of people fall into is they see a 2 down here, and so therefore they cancel out all the 2's on the top. However, you need to make sure, again, that it's a 1-to-1 ratio. The amount of things that we're crossing from the top has to be the exact same amount as what we're crossing from the bottom. So in this case, we can only cross out 1, 2 from the numerator and from the denominator. And so therefore, what we now are left with is negative 2 over 3. Alrighty, let's summarize what we've learnt today. So in this video, we explored the idea of cancelling common factors in fractions. When the numerator and denominator of a fraction contain a common factor, these factors cancel each other out. We then explored how we can apply this to writing fractions in lowest terms, which involve finding the highest common factor of the numerator and denominator, and then factorizing this out from both numbers. We then applied this idea to write some fractions in lowest terms. And that's it for now. See you in the next video.